In this screencast I'm going to look at the differentiation of an integral. And I have written out here, typed out here for you, the formula for doing this. It's sometimes known as Leibniz's formula. And here I've given it for the derivative with respect to x of an integral of a function of two variables, which in this case are x and t, with respect to t. And the limits of integration are themselves functions of x. So I think the easiest thing is to illustrate this with an example. Let's say we are asked to find di by dx if I is given as the integral from x to 2x of e to the xt divided by t dt. So I hope you can see that this is in the right form for us to apply the formula. I've got u there, the lower limit, u is x. The upper limit v is 2x. And the integrand f is a function of x and t, and it is e to the xt divided by t. So let me now apply the formula, although once I've done so I'm going to have to do a lot of simplification afterwards. di by dx is given by, and the first term in the formula is f evaluated at xv. So that means f with t equaling v, which in this case is 2x. So I have e to the x times 2x all over 2x, multiplied by dv by dx, which is just 2. And then I do the same, subtracting, but in this case with f evaluated at x u. So now t is equal to u, which is x. So that's e to the x times x divided by x. And I'm multiplying by the derivative of u with respect to x, which is just 1. And then the final term I integrate with the same limits as before, but now I differentiate partially f with respect to x. So if I do that, the 1 over t is like a constant, and if I differentiate e to the xt with respect to x, I get t e to the xt, and then I integrate dt. So you may need to stop this screencast now to check you're happy with those terms. If you are happy, let me now go on and simplify them. The first two terms I can't do much with at the moment. I'll cancel the 2's and just tidy up the exponents, but apart from that I'll leave them as they are. And now here I'm integrating from x to 2x, and the 1 over t and the t cancel, so in fact I'm just integrating e to the xt dt. And I'll do that on the next line, so these first two terms are just staying the same. And now if I integrate e to the xt with respect to t, I get 1 over x e to the xt. And don't forget that these limits are t limits, so I'm going to be substituting in for t, which I shall do on this next line. First two terms just as before. And then I've got a 1 over x e to the x times 2x, so that's 2x squared. And then I subtract 1 over x e to the x times x, which is x squared. And finally, in the next line, I can gather together the similar terms, and in fact I've got two of them, haven't I? So I've got two lots of e to the 2x squared minus two lots of e to the x squared, taking out the 2 as a factor and the 1 over x as a factor. And that is the answer to the original problem.